In this problem, we're going to talk about a population decaying exponentially and figure out how long it takes to get to a certain level. So this is, again, I've been doing this in generality, but this applies to a lot of different scenarios where exponential decay or growth is involved. So let's say our bacteria decays from 20 to 15 in only 10 minutes, and we want to figure out how long before only 5 are left. Many different approaches to this problem. The biggest thing is we need to build a model, some kind of model to work off of. So I know that if I start off at 20, and I'm going to call B the base, after 10 minutes it's going to have decayed down to 15. So for this one, I'm using the model y equals AB to the t. We can use the other model, AE to the kt. They're both equally good. So the first goal is going to be to find our B, because that gives us our rate of decay. So we're going to divide both sides by 20, and I'm going to go ahead and reduce that down to 3/4 equals B to the 10th. Now you don't need logs here to solve. Actually, you're just going to raise both sides to the 1/10, because those will cancel, and I've got my B. So I can build my model. So I'm going to go ahead and use 20 as my initial, saying that that's where it started. So my model is going to be y equals 20 times 3/4, and then the way I'm going to write this is t over 10, because I'd have 1/10 to the t. Those multiply, so I get t over 10. There's my model. I want to know when this gets down to 5. So 5 equals 20 times 3/4 to the t over 10. And now we can go to work. So we can divide both sides by 20 again. And over here I get, that's going to reduce down to 1/4. So I have 1/4 equals 3/4 to the t over 10. Let me get a little more space here, 1/4. Now here's where the variables in the exponent, this is where I'm going to employ logs. I'm going to use natural log this time. I use logs so often. So I'm going to take the natural log of both sides. The reason I do that is that allows me to pull the exponent on this side out front. So I have ln of 1/4 equals t over 10 ln of 3/4. Alright, not much left to do to solve. I'm going to multiply both sides by 10. So that'll cancel the 10 out over here. And divide both sides by ln of 3/4. And I've got how long. Now typically we're not going to leave an answer like this just because who wants to hear that's how long something's going to take. Let's get it into a number that we can work with. I know that's kind of difficult for you to see. So I would put this in as 10 natural log of 1/4 divided by natural log of 3 divided by 4. And I've got, it's going to take about 48.2, and we did this in minutes. Now, that may seem kind of weird at first, because we saw, hey, we lost 5 bacteria in only 10 minutes. But remember, this isn't linear. We're not losing 5 bacteria every 10 minutes. It's exponential. So what happens is it's going to decay quickly at first, and then slower and slower over time, because it's going to be concave up.